Thank you, thank you. I love it when people give a better introduction than I could do myself. So this is the introductory slide. That was the introduction. We're going to go ahead and move on. There we go. So the value triangle has something that's been used as a thinking model for quite a while. And the idea of the value triangle is it's to teach you balance in choices. And this is one of the classic models, the good, fast, cheap triangle. And the model invites you to feel free to pick any two. You can pick something that's good and cheap, it will not be fast. Good and fast will not be cheap, and fast and cheap will not be good. Similar models exist in what we do. There's this CAP theorem thing some of you may have heard of that says that any networked data storage kind of system, you can pick any two of consistency, availability, or partition tolerance. But again, you get to pick any two, right? We can have consistency and partition tolerance, but your availability may suffer. If you like availability and consistency, partition tolerances are going to be a problem for you. This is my own personal value triangle. Nice dinner, extended family, and political discussions. And trust me, you cannot pick all three. There are times I do not want to pick two. But what we're up against in building reliable and quickly moving systems is that we need to be able to pick fast, we need to be able to pick safe, and we need to be able to do this continuously. So we have to break our model. This is something where we have to be able to pick all three. So what I want to explore with you is how we do that at Netflix. Because you see, what we're asking for is that we need to have both a cake-having and a cake-eating kind of situation in order to meet our goals. So this triangle represents those ideas. Go fast, be safe, and do it all the time. It's kind of bumper sticker level wisdom, right? Now the world would be probably a much better place if we could achieve a lot of the wisdom that's written on the tail end of cars. So that's what we're going to try to do here today. So how do we talk about how Netflix picks between these things? Now what I have to do in order for you to understand my choices is help you understand my goals or what's important to Netflix. So Netflix has a singular goal. We call this winning moments of truth. Now that moment of truth is when you or your family sit down on your lovely green couch and you have some entertainment time available. What do you pick when you have that time? Well, there's Netflix, there's books, there's video games, right? I hear some people go outside on purpose. But you have that choice to make, and when you pick Netflix, we consider it winning that moment of truth. So this is our singular goal. This is what we're after. So the decisions that we make, whether they're technology decisions, hiring decisions, software decisions, development decisions, content decisions, are all in service of this one singular idea of winning those moments of truth. Something else to know about those moments of truth is that they're fleeting. They come and go quickly, so that also has to be a factor in the decisions that we're making. So some of the things that we have to have in order to win those moments of truth. I have to have compelling and interesting content that is compelling and interesting to at least hundreds of millions of people. That's not a short order. How many of you ever have taken a family out for dinner? Thank you for participating, I appreciate that. I have a family of 6 at home, and I've gone through this exercise myself. We often spend more time discussing, cajoling, negotiating, figuring, arguing, than we do actually enjoying a nice dinner. Interestingly enough, content is the same way. Many different people have many different desires and choices in that moment that I want to win, so I have to have a breadth of content available. I also need to make sure that my service is available on a myriad of devices. Netflix currently is available on a few thousand different models of devices. Why is that important? Well, when that fleeting moment becomes available, I don't want to lose it because you happen to have a phone in your hand instead of sitting in front of your television, or you have a game controller instead of a tablet. So we need to have Netflix available on all of these different devices. Entertainment itself is also highly variable. There's a local element to entertainment. Now, you can take some of these global blockbusters and do some subs and dubs for them and send them out, and you'll win some of those moments of truth. But because storytelling is so local, it's such a part of where we are, that we need to make sure we're also producing content that's made locally and written locally and produced locally so that we win more of those moments of truth for more of our customer base. There's also this idea, maybe you've heard of systems availability. If my systems aren't up, people don't get to press play either. Those are some of the evident kinds of things that we have to have available to us, right? Anyone who's not a part of Netflix or not a part of the entertainment industry could understand those kinds of things and why we need to have them available. But behind the scenes is where a lot of the difficult decisions are made. Making things simple and easy is often hard. And much like the iceberg model, that evidence stuff is what's above the waterline. Our hard decisions, the things we have to do, the work we have to develop, the things that exist so our customers don't notice, that's what happens below the waterline. So if we think about these being difficult choices that we need to make sure we hide from our customers, our value triangle now takes on a different layer of complexity. So let's start diving into that. If we look at fast is an important component for Netflix, and we prize that velocity of innovation. We have lots of things going on and lots of changes that we need to make. If we go back to that content idea, Netflix has released thousands of pieces of content in the last year alone. Now, some of you might be thinking, Dave, how hard could it be? You have the content. We've heard people talk about encoding video. That's a bit of a solved problem. And there's that CDN thing that you have. You push them out there, and now they're available to people and they can press play. So what's the difficulty? That sounds pretty simple and pretty fast. What you need to understand is that ability to allow our customers to press play and stream those video bits to their eyeballs is the end of a very long pipeline. That pipeline is where we need to make sure that we're moving quickly. So that velocity of innovation is important. So developer velocity is key in what we do. We have a very fast-moving business. The entertainment and media business itself moves very quickly all the time and from different directions. So we have to ensure that the developers that we've entrusted with making these decisions and making this product are able to move quickly. We also have some other challenges, maybe that are on that line of evident or not evident. Our content is changing. It used to be when Netflix streaming started, we'd get the content, we stream the content, right? Well, there's new things going on. There was an idea we call branching narratives. Started with some kids' shows. There's one called Puss in Books that allowed young viewers to participate by making decisions as the story went along. Black Mirror Bandersnatch was the same kind of thing for an older audience where you're able to make those kinds of decisions. If you're a comedy fan, there's Seth Meyers' latest little bit on Netflix that actually has a little button in the corner that allows you to skip politics if you don't want to hear those parts of the bit. Right? But now it's a little bit more than streaming. It's much more interactive. And that requires that my front-end teams, my back-end teams, my data teams, everyone involved has to continue to move quickly. So what does Netflix need in order to maintain that velocity of a varied set of engineers solving different problems? We found an answer. Mechanical keyboards for everyone. We've determined if developers are given up to 7 different mechanical keyboards that they can use to solve any potential problem that comes in front of them, developer velocity is ensured. I may have a little bit of a mechanical keyboard problem myself, so this is even funnier to me and less funny to my wife at home. So one of those first things was this microservices choice. That idea is when you have a large engineering organization, you want to separate what they're working on a little bit, and microservices gives you some of that answer. As you can see, this is a map of some of the microservices that make up your Netflix experience. I'll give those of you taking notes a minute to scribble this down. That was funny. So microservices, they do certain things. They're a component, right? But they aren't the entire answer. So imagine if you will, for a moment, that we have these hundreds of microservices, but maybe there's one microservice there that does kind of some work of coordinating or communicating for other microservices, or they have to call into this service to gather some data. So this becomes a key microservice. Now imagine, if you will, that it's also very important that this service operates for our customers to be able to do things like log in, enjoy the service, make selections. Now also imagine, if you will, that it has a creative name like API. At this point you can stop imagining that's absolutely what we have. So what we had is we had an API team, and that API team ran this very important service. And they're a very careful, considered, talented, capable engineering team. And they would deploy their service every 2 weeks. And during that time, they're testing code, they're integrating with their partners and dependents, working on things, making sure that tests are passing and agreements have been met, and if there's any other things that need to be adjusted, that kind of work happens. So they were running a relatively safe operation, right? They were being very careful. However, there's an effect from this kind of safe operation you can consider ripple effects, right? There were a lot of teams running not as complex a system that were dependent on that 2-week schedule as set by this centralized API team. So what happened? Those smaller teams ended up managing lots of multiple code sets, right? They had the current version that's out there running now that we're doing hot fixes and patches against, and then we have this new version here that's going to be coming out as soon as this API team manages to deploy. And then we have the effect of all this available free time. So what are we doing? We're building new features, and they're off out here in the future, right? And now we have multiple change sets that they're trying to manage. So it means that some of that creative time, some of that development time that we use to keep up with the velocity of our particular industry went into managing lots of change. And it also created a problem then for the API team as well, right? Because they have these different teams that they're coordinating with, and they know that there's work going on there that they have to be careful of and they have to manage. So while we had a microservices technology, some ways in behavior, we had a bit of a distributed monolith. And my pretty ripple picture really looks a bit more like this, because as those people made changes to different parts of the system, they created their own ripple effects. And those ripple effects start crashing into each other and creating an entirely new set of problems now that needs to be managed and takes away from time in developing new features. This is pretty costly, right? We had a really high coordination cost as plans were on hold and schedules were negotiated and things had to work together, and heaven forbid something happened and we couldn't keep to that schedule, or something broke and we had to move backwards. That reduces a lot of flexibility for these teams that are charged with keeping up with a quickly moving environment. And those coordination costs, those coordinated changes, those meetings resulted in a lot of slowdown. Slowdown for a quickly moving industry isn't healthy. It's not good. It doesn't meet those goals of winning moments of truth if I can't get these new features out there and available. So, how does Spinnaker enable fast for these kinds of teams? Well, if you think about some of those basic tools that we're all familiar with, whether it's the pipelines or the automated canary analysis, right? What did it do? It allowed teams to move more quickly and with higher confidence. So now if we go back to that imaginary real API team that was developing the software, once they adopted the deployment technologies and methodologies, they went from deploying once every 2 weeks to a nightly canary and a daily deploy of a major service. For those of you doing the math at home, that's approximately 14 times faster. The team then also gained trust in Spinnaker's behaviors, right? We no longer had to have one of these grand ceremonies where we call everyone together and we disturb their focus, and everyone looks at their own little bit of the system, and someone runs whatever magical bash script happens to deploy things, and everyone holds their breath and we hope nothing breaks, right? We didn't have that anymore. Also, that released some of that back pressure, right? Now I have multiple teams that are no longer gated by a 2-week deploy. They're moving more quickly. They're deploying one every day, 2 or 3. It also gives us the added benefit that they're deploying smaller code sets, which means that when something doesn't go as expected, they're able to more easily logic about the changes that they've made to the system. So by adopting this, everyone moved much, much more quickly. So now if we move on to the next point of our value triangle, we have safe. Now reliability and availability are deep and complex topics. And I want to take a moment to thank the conference organizers for giving me your next 6 hours so that we could dive deeply into these particular topics. Of course, I'm kidding, they only gave me 4 hours. How does Netflix think about availability and reliability now that we have people moving very quickly? So, this is a reliability tactic. Never change anything, right? Once we get the system up and working, it's stable, now we just don't touch it, right? It's okay, we got everything going, our failures aren't being seen by anyone, customers are getting what they expect, nobody touch anything, right? It's not possible, of course, because any kind of running system experiences some amount of fluctuations, but we also have that quickly moving environment. The only option that we have is change. We don't get to stand still. We don't get to hold steady. So the question for us is not if we get to change. That question is answered for us. With our business and our environment and the goals that we have to change. That is not a choice for us. So the question becomes, how do we change safely? Prevention is a reasonable way to spend some of your reliability cycles. Now that's reasonable prevention. Now what do I mean by reasonable prevention? There are certain things we know are coming at us and certain problems that we can understand. For instance, years ago, when Netflix moved from being in the data center to being in the cloud, our cloud provider made us some promises. One of the first promises was that those instances you're using, those virtual instances, will disappear out from under you. First promise. So we know we had to find a way to design systems so that that loss of an individual instance wasn't going to take down our running applications. As Andy mentioned last night, Chaos Monkey was the beginning of that story, and Chaos Monkey still runs around today, randomly killing instances inside of Netflix. Second promise. You'll have little control or view over the hardware, software, and networking upon which your system relies. Therefore, you cannot design your software in such a way that you're encasing or encoding assumptions about certain things, because that's going to change out from underneath you. And most of the time when those things go well, you won't even notice that those changes are happening. So that was our second promise. The third promise we received is that your bill will show up on time and your payment better too. Some other things we think about in reasonable prevention. On the operations side of the world, we have monitoring, we have metrics, we have measurability, and we have observability of our systems so that we know what they're doing and how they're reacting in this environment. Delivery is a portion of that as well. It's very important that we're able to use tools like Keynote, that automated canary analysis, to make sure that this new code, as we bring it out there into the world, behaves the way we think it does when it actually crashes into that reality of a turbulent production environment. Able to do things like environmental verification, make sure that the world is as we expect it to be before we send that new code out there. We also know that in using the pipelines, we get the same bits constructed the same way, tested the same way, deployed the same way every time. But that reasonable prevention only goes so far. There's a key challenge with prevention. You have to be able to understand the problem state. And you have to be able to understand those rough edges of it. Now again, this happens easily in certain ways. Right? I think probably all of us here have experienced retries. We didn't get what we expected the first time, how about you try it again? This is encoded not only in our software, but in the operating systems and TCP/IP stacks and things like that that we rely on. But that only covers a certain amount of problems. I know that, for instance, Netflix has experienced problems where the only way this problem was going to show up is if these 197 variables had these values in this particular order with this phase of the moon for this particular problem to come up that we could never envision. So that's the problem with prevention as part of your strategy, is that you have to be able to understand and envision the entire problem space in order to do it. So that's where I'd argue that your ability to recover from problems is greater than your ability to prevent those problems. Reasonable prevention is a start. For a lot of places, this is where their reliability efforts end. Because failures will happen, no matter the skills or expertise levels or experience levels of your team, whether you choose latest and greatest technologies or you're more a fan of choose boring technologies. Whether you live in the cloud or you're surrounded by that pleasant hum of a data center, those failures are going to happen. So your question here is whether or not your customers get to experience those failures along with you. So with that in mind, how do we talk about recovery being greater than prevention? So one of the first things that we look at is this idea of graceful degradation. The idea here is that something for our customers is better than nothing. Now we'll go back into imagination. Imagine that one of those microservices creates that UI that you've seen. For those of you that are familiar with the Netflix service, there's a list of movies, right? Now that list of movies is personalized for every account, for every profile, every day. So imagine that there's a microservice building out that UI, and there's another microservice there that handles that personalization information, and the UI service calls into the personalization service, and nothing comes back. It's screaming into the void. We have two options for how to answer that, right? Number one, we display what I call our most popular Netflix series. It says, cannot connect to Netflix, please try again later. It's an option, and we've occasionally chosen that option. But what if, imagine this, we could teach that UI service that in the case that it cannot get Dave's personalized recommendations, that maybe it shows me yesterday's or something, maybe locally relevant or even a static list, right? Something is better than nothing. So by designing the systems that way, I've taught that UI service how to recover within milliseconds. No humans had to get involved, no one was paged, no alerts went off, no graphs fell off. The system behaved on its own and performed that recovery. Another idea that we use, regional evacuation. So Netflix operates in 3 of Amazon's regions. And we mentioned earlier, Chaos Monkey goes around shooting instances in the head. We took this a little bit further. Imagine if a region is now your container for a particular problem. Something is affecting that entire area. Again, we have the question of, do I allow my customers to come on that ride along with me, right? Remember, we have hundreds of microservices running across thousands and thousands and thousands of instances on top of a framework of network systems, machines, and hardware that we cannot control or we cannot see. That's a complex problem to debug, even if we have the most qualified people in the world available. So again, our question to the customers, come along with us. So we developed a system called Chaos Kong at the time. And what it allowed us to do was completely evacuate customer traffic from any one of those Amazon regions and move all of our customers out to other parts of the world, most of the time without them even noticing. We literally built a system that allows us to run away from our problems. Spinnaker is also an important part of this. A common reliability question that SREs deal with whenever there's an issue is, what changed? We have a large, complex system with lots of people making changes. There are thousands and thousands of changes to our production systems every day. So we built a system that records all of those changes in our production environment. Now that's great, right? I know exactly what changed when. I know when the problem happened. Now I can point my finger at it and say, this did it. There's a challenge there, right? Knowing what broke things does not fix my customer's experience. So using things like this single action rollback feature allows my individual software teams that have that same data and information to make changes to recover the system on its own when it cannot recover when it can't recover itself. Again, without involving a lot of people. There's no, hopefully, call out to the centralized SRE team, right? We've now given those teams the tools that they need to recover the system on their own. We've had some fabulous wins from it. Now, it's hard to kind of codify some of those because really what I would need to be able to give you would be a list of all of the outages that never happened. But we call this idea distributed reliability. A lot of us invest in distributed systems because we understand some of the benefits that we get there. By also distributing the capability throughout our engineering teams for people to recover and handle these things on their own, we distribute the reliability also through the socio side of our socio-technical system. So that's how Spinnaker enables safe for us at Netflix. Because leaving the system as it is not an option for us. We have a quickly moving environment that we have to respond to. We know that reasonable prevention is where we start our reliability work and not where we end. And that by giving our engineering teams the capability to do these kinds of things on their own, as well as teaching our systems how to recover on their own, we get more safety for our customers. We get an environment that for them always just works. Now we have the third and more elusive point of our triangle to talk about. We have the continuous part. I have seen teams achieve fast and safe deployments, oftentimes once, right? And we do that through that big ritual. We get everyone involved, we pull everyone together, we distract them from what they're doing, everyone takes a different part of the system to be concerned about, and we step through the deployment together, and if it all goes well, we do it fast, we've done it safely, everyone wins, and it's a really, really high cost. So we can do that once, maybe twice. But our goal here is to be able to do this continuously. Remember, we have those thousands of changes in that production environment all the time. We can't do that if we have to call everyone together for some form of ceremony. So one of the things that enables continuous for us is consistency. That ensures that whatever packages our engineering teams are putting together go through the same steps using the same source in the same way with the same tests and the same verifications every time. Those pipelines provide another thing that's kind of nice, especially from a reliability standpoint, is they provide a nice set of documentation for the intentions of the team that designed it for what they wanted their system to go through. We've also seen some teams use their pipelines not only as documentation, but training material for new team members to help educate them about the behavior of the system. We've used this quite a bit. We leverage it to tremendous benefit. However, there are still a lot of details to manage. As it stands now, teams deploying software not only need to know everything about their application, how it behaves, how they want it to behave, how it needs to be distributed, they also have to know the details of the infrastructure and the environment that's going on top of it. They have to understand all of those wiring and those pieces that go together. That's a lot to manage. Now, the teams that do this, they're very capable. They understand these things. It's possible for them to do this, but that's quite a bit of cognitive load to continually manage when this is a perhaps daily kind of thing. Deployment templates, canary analysis, regularity, and consistency cover some of those sharp edges. But there's still that tight coupling with the infrastructure that's required in order for these teams to be successful. So I think there's a better way for these teams to be successful and reduce the cognitive load, and we call that managed delivery. There's some great benefits through and from managed delivery that people much more capable and knowledgeable on the topic will be talking about than myself. But from a reliability and infrastructure standpoint, this does something very, very nice. Not only does it reduce the cognitive load on those teams by making it easier for them to describe what they want to have happen, it breaks that tight tie that currently exists with their knowledge in the infrastructure. It allows us to break those apart. So by describing what I want as my end state and the requirements of my application, I now free myself to do my application work, and I free my infrastructure teams to make the changes they need to make. It's no longer a highly coupled, difficult kind of thing. Earlier, like we saw the coupling with the API service and the smaller services behind them, we have this similar kind of coupling now between application teams and infrastructure teams. If your infrastructure teams ever have to do some kind of hardware or network migration, it's really, really complex. They have to spend a lot of time with application teams going through all of these bits and designs and pieces. Now with managed delivery, that's no longer required. I already know their requirements, I already know their desired end state, and I have the freedom to move on my own while still meeting their needs. So that's an idea, some of how we enable continuous. Fast, safe, continuous, consistent. Through managed delivery, we're now breaking more coupling. Reliability is enhanced because the deployment teams that are working on their applications now have less to worry about. The infrastructure teams can make changes with the knowledge that they need. And again, all of these things happening thousands of times a day while my customer experience is ordinary. I want to be able to make all of these changes, be able to move these parts around without my customers noticing. And that's one of the most important things for us in picking this, picking all 3 points of our value triangle. Those combination of smaller code sets, nightly canaries, enable teams to move much more quickly. Safety is enhanced when it's easier for teams to logic about how their changes to the system have affected things, or how to decouple from infrastructure. And we're able to do that continuously by allowing everyone to move independently, have those smaller code sets, that less to manage, for infrastructure and application teams to be able to move independently. So that's how we pick fast, safe, and continuous, all 3 points of the value triangle at Netflix. My name is Dave Hahn. This is where you can find me on the internet.